Hello everyone, welcome to Pepcoding. So in this video we are going to discuss a question that is validate BST. What we have to do in this question, we have to tell that if the given tree is a valid BST or not. So what is a BST? We know that in BST the maximum value from left subtree should be smaller than the current node that we are at, that is the parent node of that this left subtree, and the value that is stored at the node that is at the parent node. So I'll repeat myself. What this means, that the maximum value from the BST from the left subtree of a binary tree, of a binary search tree, should be less than the value that is present at the current node. Similarly, here minimum value from right subtree should be greater than the root value, that is the current node's value. This will be more clear if I draw subtree, draw binary tree, binary search tree. 13, let's say 10, 7, 11, let's say 20, 18, 25. Here you can see that maximum of this tree. What is maximum of left subtree? Maximum of left subtree is 11. And what is minimum of this left subtree, right subtree? The minimum of this right subtree is nothing but 18. And if we put 13 in between, you can see that it is following this pattern. It is invalid BST. And this thing has to be true for every given node. Okay. So for example, if we take 20, you can see that maximum of minimum of right BST is nothing but 25, and maximum of left side of the tree, that is left subtree, is nothing but 18, right? So this is also following for this. So what we have to do, we have to tell that if the given tree is a binary tree or not. We also know the another property. The next property is nothing but, we know that if it is a binary tree, if the given tree is a binary tree, then in order of that tree will be a sorted, will be in a sorted order. See that if we take an in order of this tree, what will the value? 7, 10, 11, 13, 18, 20, and 25. We can see that it is an valid. These values are in sorted way. That is, first 7 is coming, then 10 is coming, and 11 is coming. So if I have these values, can I check that? Can I determine that if the given tree is a BST or not? How we can determine? What we can do? We can take a previous pointer pointing here, the current pointer pointing at the current node, and we can check that if previous is smaller than current, then it is true thing. You can proceed. That is, you can go to the next location and check there also. When this condition will be false, it means that this given tree is not a valid binary tree, a valid binary search tree. Let's see that for this condition. For this condition, 7 is less than 10. True. Okay. Then iterate here. It will again check for 10 and 11. Then for this. Then for this. Then for this. Then for this. And when will be this loop ending? This loop will end when we are done with checking all the nodes. But when will this when will this condition fail? Let's say that if I'm at this position, or at this position, let's say, and here instead of 18, if here was a value, let's say smaller than 13, that is 12, let's say, if here it was a 12, then can I say that this condition is not becoming true here, this is getting false? So when this kind of condition we encounter, then we have to return false. This means that this is not a valid BST, right? Now similarly, this will be going to this is what our approach is going to be. But instead of taking an in order, we'll do some work in the in order area, that is the in area. Now let's take an BST 13 10, say 5 11 20 18 and say 25. This is, let's take example of this binary tree. To do that, to do the recursive calls and to do all this, we'll be using a stack so that it will be more easy to understand. It will be easy to understand. Okay. Now, what we are going to do here is let's see what is going to be our approach. Okay. I'll be taking a sorry, I'll be taking a variable named as prev. Okay, this is going to, let's say p. This p is going to store nothing but previous value. Initially, this is, let's say, empty. Okay, this is going to be null, and I'm going to have like current value. This c is nothing but the value or the position of the current node. This we don't have to maintain because while using the recursive call, it is going to check automatically. Okay, because what we can do this roots value. So root value, or let's say root val, we can use this for current. Okay, so we don't have to maintain a new variable for the current value. So now what is going to be our faith? Our faith is going to be that this 13, or so that's for this faith is always for the smaller problem. So this 10 is going to say that hey 5, that is my left child, give me the maximum value, or let's say the not the maximum value, because here we don't have to check for the maximum value. What we have to ask our children, this 10 will ask his left child, tell me if you're a binary tree, if you're a BST or not. Okay, what this 10 will ask to 5? It will ask that, hey my child, are you the binary tree? Like, is your family a binary tree? If yes, then return me your value as true. And this will also ask to 11, hey 11, my right child, are you a family of a binary tree, binary search tree? If yes, return me. Then I'll tell my father, that is, I'll tell my parent that we are binary tree. Which means this 13 is going to ask to whom? To 10. That hey 10, tell me that you and your family is a binary tree, binary search tree or not. Okay, tell me that you and your family is a BST or not. Similarly, this is going to ask to the right child that hey 20, tell me that you and your family is a BST or not. If you both are a BST, then obviously our whole family, including me, is going to be a BST. But if any one of you is not a BST, then our family is not a BST. Okay, this is what our faith is going to be. Right, now let's start. First, what we are going to do, we are going to make a call to whom? Left child. And then we are going to make a call to right child, and in between we are going to do something that we'll look now, that we'll see that first I call to, from 13 I call to 10. Okay, so currently at the very starting point, current position was nothing but 13, but when it made a call to left child, then its value became 10. Okay, similarly it made a call to its own child, value became 5. Now this 5 is going to make call to whom? To the null values. Here we can say that our base case is nothing but when a null value is encountered, return true. Why return true? Because we know that a single node, if a binary tree has only one node, then it's a binary search tree. We can say that it's a binary search tree, right? Similarly, from null, from when we encounter null, we are going to return what? Tree. So how this is going to look instead? 13 made a call to left child, 10 made a call to its left child. From here we go to 5, 5 made a call to its left child, and while coming from 5 we got an answer true, that from its left child it is saying that yes, me and my family, that is I don't have a family, so I'm going to be true. So I'm a BST. I'll return I'll return answer as true. So here we can write that return true. Okay, instead of this, we'll see this in code only while we do code. Right now, let's try to understand what is actually happening. So from here, when it made a call, it is going to return true. Okay, so after this left call, but from here, when it returned true, the left call of the 5 returned true. Now, while before making the right call, we are going to do some work. What is that work going to be? We are going to check that if the previous value is greater than the current value, then return false. Why return false? We can say that we have discussed in this only. If the previous value was greater than the current value, then this means that this is not a valid BST. Therefore, this condition is going to check that if the current value is smaller than the previous value, that is, if I am smaller than my child, then obviously I am not a BST. Okay, if my left child, okay, if I am smaller than my left child, this 13 is saying that if I am smaller than this 10, then how can I control him? How can I, let's say, in a simple terms, how can I say that I am a BST? Because what was my property? My property was that I am uh, more dominant to my left child, and my right child is more dominant to me. Okay, my right childs are more dominant to me. This is what we can say, or this is a kind of story we can frame here. So, after doing this, what we are going to do? We are going to see if the right child, the current value is smaller than previous value, then we are going to return false. But if not, then our current was here, right? And initially our previous was nowhere, that is null. Now, if this is not true, then what we are going to do? We are going to assign the previous value, that is assign the p to this 5, okay? And my current is going to be now this position, okay? Now that is going to be C, okay? Previous value is going to hold the current value. Why we are doing this? Because we have to update the pointers here. This is doing the same thing, that we are going to update the pointers. Now let's see. Right made a call to, say 5 made a call to its right child. From here it returned true. My previous is now standing at this position, and my current was not here. Sorry, that's my mistake. My current was here. It returned here. Okay. Now what is my current? My current is this 10. Okay, my current is this 10. Both the calls for 5 have been done or have been executed, so it will wipe out of the stack. It will wipe out of the stack. So from the left side, that is from the left call of the 10, what we received? We received true value. Now my current is standing here. Now before making to call to 11, that is before making call to right child, before making this right call, what we are going to do? We are going to perform some operations. We are going to see that what is my current value right now? My current value is 10. What is my previous value? My previous value is now 5. It is going to check that is previous value greater than current value. If this is going to be true, then this is not a BST. So is 5 greater than 10? No, 10 is more dominant than 5. Therefore, this is a false value. So if it is a false, then we don't have to return false. It will just not check. It will not go inside this condition. inside this if loop, and it will come here. So when this comes here, what is going to do? It's going to update its value. Previous is going to be become 10. Now after this, we are going to make a call to right side. From this right side, again same thing, null null. Now when a call made to right side, where we are standing at 11. Now 11 makes a call to left child. From there we get true because there is null. Now before making call to right side, what we are going to do? Now my current is 11. What we are going to do? We are going to check that if 10 is greater than 11. If not, then previous is equals to 11. What we have to do? We have to update this value. It's going to be 11. From here, it is going to return true, right? First, we made call here. Then here, before making this call, we updated the value. Now we are returning true. Now my current is still 11. Now this, after both the calls of this 11 done, what we are going to do? We are going to wipe this out of the stack. This is going to be wiped out of the stack, and it is going to return true value, true answer to this 10. So from the right side, right call, we got true for 10. So I hope with this you are able to understand that what actually we are doing. We are doing nothing, but we are doing the same thing that we are doing here. Just this previous value. Why we are updating the previous value? Because we want to update our counter. What we are doing here? We are updating our counter. This is doing nothing but the same work. Okay. So now where we are currently, I'll just erase this. My current values, both the calls for 10 is done. Now this is going to return here, and let's say it was updated to 11. First it was, let's say, here. Okay, from here it returned here. Now my current is still 11. Here it got current 10. My value is still 11. Now it is going to return true. That is, now I will do this, erase these things. This, okay. Now from the left side of the 13, we received what? We received true value, and my previous is 11, right? Now this is going to check what it is going to check. It is going to check before making the call to its right side. It is going to see if my current is here now 13, if 11, that is the previous value, is greater than me or not. If it is not greater than me, then it is a safe thing to play. That is, we can go to the next value. That is, I'll make a right call, but before going to the right side, what I have to do? I have to update it with my value. I have to update previous with my value. Now my previous is here, not here, and my current is here. Now 20 is going to make a call. That is, call to 20. 20 is going to make a left call to its left side. Similarly, here we can say 18. 18 is going to make a left call. Here none, null. It is going to return true. From here we are going to return. We are going to get answers. Now before making a call to right side, where we are standing right now, we are standing at 18. Before making a call to right side, it is going to check that if the previous value, that is the value before me, was smaller than me or not. So it is going to check that if 13 is smaller than me, yes, it is smaller. Then what is going to do? It is going to update it with its value. Okay, and then going to make a call to our what I am saying, right side, and from there it is going to return true. Now this is going to return true. So therefore, from the left call of the 20, we are getting our answer true as an answer. Here we can notice that this previous and current are nothing but going in a in order direction, like in order kind of thing. That is, first I can say that my current was here, right? Then current was here, then current was here. Now we can notice that the very first element, when we start the in order traversal, very first element is nothing but 7. Here it is 5. Okay, so in what is going to be its in order is going to be 5, 10, 11, 13, 18, 20 and 25. Okay, so we can see that at 5 it checked that if my previous value was smaller than me or not. And what was my previous? My previous was null here, right? So 5 is obviously greater than null. Therefore, it iterated. So for current here, for at the initial point, current was here and previous was here. After this, previous came here and current got here. You can see that when we return to this position, we are at 10. 10 was our current check. Now before going to 11, I have to check if this current is greater than the previous value or not. So what we are doing, we are doing the same thing. Previous value, if current, that is same thing, that is for previous value greater than the current value, then it is going to be false. So what we are doing, we are traveling in order traversal kind of thing. So I hope that you are getting what I am trying to say. We are going in this way. Here, then after here, then after here. And while going down the path, or while traveling in order, we are all simultaneously checking that if this is a binary tree or not. So let's continue with the traversal. Sorry. So for both the calls for 18 is done. Now we are going to wipe this out of the stack. Now, before making call to its right side, what 20 is doing? 20 is going to check if 18 is smaller than 20. Sorry, 18 is smaller than 20. Here, current value is 20. Yes, it is. Then it is going to update it. Okay, and going to make a call to 25. 25 is going to make a call to left child. That is going to return him true. Before going to the right side, what I have to do, I have to see that if 20 is smaller than, that is the previous value is smaller than my current value. If it is, then it is going to make the right call. But before that, I am going to update this, that is 25. Now similarly, when both the calls for this is going to return him true, this is the call, this is going to return him true. And when both the calls are done, we are going to wipe this out of the stack. Now this is also done. So for both the calls of 20, we got answer as true. It is going to return what? It is going to return true. So both the calls are done. And here also for 13, answer came as true, and both the calls are done. Therefore, with this, our answer is coming true. So I hope with this that this dry run was clear to you all. Let's now move on to the code part. Now, to code this, what we are going to do, what we have discussed, first there is going to be a left call, that is called to my left child, right? So I'll make a call to my left child. Similarly, I'm going to make a call to my right child, right? Now, in this in area, that is the area between these two calls, I have to do some work. What was that work? Here pre-val is already given, so I'll say if my pre-val is greater than what? The value at my root, that is at the current node, the value at my current node is smaller than pre-val, then it is a false statement, then it is not a correct BST. Yeah? False. I have to return false from here. And where is going to be my base case? My base case is going to be if root is equal to null. Then what I have to do? I have to return true. That is, there is only one element in the whole BST, right? And to minimize the calls, that is, I will explain you what I am doing here. First, I'll just write this thing, and then I'll explain that what actually I'm doing here is, if eval is false, okay, here, put here, okay. So what I just did is, what I did here is nothing but I said that, let's say we are at this condition. If here, instead of this 20, let's say here it was something like 17. Okay, so we can see that this is not a valid BST. This is an example of invalid BST. So here it is 17, but here it is 18. So we know that a property, that this property, according to this property, 18 cannot come at this side. So if I get a false from here, do I have to check for, for the further cause? So from this side only, if I get false, no need to go and check for this the right side. So not to go at the right, not to go to the next call. That is, if I'm getting false at any level, if I'm getting that, if left by if the left binary side for this side, if the left subtree, if I'm getting false value at any position, that the family of that BST, that subtree is not a BST, then I don't have to check for the right side. This is what this call is. This is what this call means. Okay. So with this, our code is complete. Let's try to run this code. And there is some error. Okay. If root is equal to null. Okay. Instead of this null, what I have to write? Capital null. This was the mistake. Okay, it is being accepted. Let's try to submit this code. And it is failing for one test case. Let's see what is that test case. Just it is going to be what was the expected output? Expected was true, sorry, false, and obviously our answer is going to be true. That's why it was going to fall. Let's check where we are going wrong. Okay, if I made a call to write, first I'll make a call to yes. What is what we have discussed? We have discussed that. Right? What was the work that we need to do? This recursion is handling the traveling part. What was the work that we had to do, that we are supposed to do? We are supposed to do this two things. First, we have to check that if the previous node is smaller than me or not. Then if that is false, that means if this is not executing, then we have to initialize previous as the current node. And this is what we have not done here. You can see here. We have checked that if here we have checked that if the previous value is smaller than or smaller than me or not. If preval is, write this in bracket. If preval is smaller than me or not. If preval is greater than me, that is, if preval is greater than me, then return false. Now I have to update preval is equals to, if this is not executing, then what we have to do? We have to update it with the current value. Okay, Now let's try to run this code. It is being accepted. Let's try to submit this now, and it is being accepted. So what was our mistake? Our mistake was nothing but we did one thing but we forgot to do the second thing. So with this, I hope the code was clear to you, and also the dry run was clear to you. So thank you for this video. Let's meet in the next video.